Good morning, everyone. My name is Tom Cherryhomes. I am the firmware engineer for a little project called FujiNet. And for those of you who don't know what FujiNet is, it's an 8-bit network adapter, but a network adapter that's useful for 8-bit machines. So it does everything that you would think such a network adapter would do. It provides a virtual disk so that you can take and load software and save data to and from either the local SD card storage or from the network. It doesn't matter where. It has a virtual printer so that you can take and print from Print Shop directly over to a PDF to a modern printer. We have a built-in PDF rasterizer. It has a built-in modem so that you can use existing comms programs and call BBSs and the like. But the most important thing, I think, of all of these things, once you get used to the disk, once you get used to the printer and the modem, you now have a virtual network adapter with a ton of different protocol adapters that can talk to modern internet services because of the processing power that's in the ESP32 that we use. But how did we get to this point? Well, ironically, this started in the summer of 2019 when I met up with Joe Honnold. He calls himself Moswald on Atari Age. And he had been spending the last 2 years working on an ESP8266 Wi-Fi modem prototype. And in fact, if you literally see what we have here, and it decided to take, gosh, screen size changed. It was supposed to put that on the right. It's a prototype machine that was really not much more than just to handle the passive bus interface to the Atari. And the majority of the processing was handled on the ESP itself. And it just started out as being a modem. Well, I asked a very innocent question. I asked him if the command line was hooked up. And he said yes. And the next thing that we knew, we started work. Oop, wrong thing. Apologies. Let me just turn down the volume because we don't need it. We started working on disk emulation, simulating an Atari disk drive, making it look like it. And what we found out was that it was very easy to do so, and that the E8266 had more than enough power to do so. And this ultimately culminated in us doing the final test here to boot Jumpman from DigitalOcean some 1,000 some odd miles away across to the Atari, and the Atari was none the wiser. The funny thing is, when this happened, the reason that this video exists is because my development board broke. My development board broke at the exact moment that we had finished a build. I had moved the cable over to the target device, and one of the pins broke off the cable. I don't have a soldering station, and I should be nowhere near a soldering iron because I have cerebral palsy. So I'm basically frantically calling and messaging Moz and going, please, dude, grab the latest build, test it, this will work. And that is literally, without even batting an eye, he turns on the camera and records this video, booting Jumpman here. And you'll see right here that when we finally got it working here, this wasn't optimized at all. It's literally running very slow, loading each sector individually for each UDP packet. But it worked, and it worked better than we had ever imagined. And the rest is history there. So at that point, as we started putting things together, people started helping. Slowly but surely, Jeff Pietmeyer came in, and he was going to say, you know what? If we can do disk drives, we can do printers too. And so he started working on that. And along the way too, we made the decision, because we were working initially in Arduino and doing everything as Arduino sketches. We're like, we need something. If we're going to break this out into modules, we need to make this nicer. So he brought us into Platform IO and helped break out the code and modularize it, make it nice and neat for production. It worked out really well there. And not only that, in the process of that, he was also working on the printing code. And we discovered as we were working through our tests on the 8266, and Jeff was working through the printing code, it dawned on us very quickly that we couldn't cram a PDF renderer into 80K of RAM. You just can't do it. Oops. So we needed to go to a larger platform. And thankfully, there were no users at the time, so we could basically rip the Band-Aid off and do this very quickly. We moved over to the ESP32. Steve Boswell came in. He made our FujiNet logo, which you can see on our T-shirts and stuff. And he also made one of the 8266 prototypes. If you guys are lucky enough to have one of these, which since it looked like a candy bar, we called it the Mars bar. If it's going to come up, yeah. 8266 on top, connectors on the bottom here. And in the process, we actually wound up finding all the different ways that we could take and machine our own connectors using 3D printing and using appropriate pin sizes and whatnot. And we addressed actually an interesting problem in the Atari community where nobody knew how to make replacement connectors for the Atari peripheral bus because they use a special connector that Molex doesn't make anymore. So we had to take and come up with that. Finally, in the first part of 2020, Oscar Fowler comes on board and is absolutely indispensable in taking us from the Arduino framework, which we were still using in Platform I/O. We had broken everything out in Platform I/O, but we were still using Arduino functions. He brought us into the vendor framework, ESP-IDF, which gave us a tremendous amount of flexibility and made the code that much more efficient and faster, and paved the way so that we could take code that from other places, such as POSIX code from different open source projects, to be able to bring in directly and use on the ESP32 itself. An example of that is libSSH, actually, which is how we get our SSH support. It works as is. And so many more. This was followed immediately by rapid code expansion. And Andy Diller actually put this little diagram together roughly about 7-8 months ago, showing the progress of how our code base started and how it quickly mushroomed over time as we moved from one platform to another, and added more functionality here. It's absolutely mesmerizing, and I can give you guys the link to this if you want to take a look at this, because you can literally see the entire project take shape and how it takes and breaks out. And you can see all the points at which we made major code decisions. But this all happened very quickly. In the span of roughly a year and a half, we went from a single platform that was the Atari 8-bit, and we started branching out and modularizing even further. First going to the Coleco Atom, then starting work on the Apple II. In the meantime, Moswald starts working on the Atari Lynx support in parallel. We're breaking all these things out, adding support for more peripherals and things that we could take and pull into. And in the process, we slowly work our way up to the code base that we have today. Let me pull that away. Apologies. For some reason, my touchpad is acting very funny today, and I hope you bear with me. And yes, a little sneak peek there. We're looking at RP2040 chips for bus front-end processing right there. So that brings us essentially to Coleco Atom, the very next platform. And that happened as basically a fluke of circumstance. I happened to be looking over the Coleco Atom hardware manual, and I noticed the section on the AtomNet. For those of you who don't have an Atom, which is probably the majority of you, because almost nobody saw the damn thing, they hooked up disk drives and the printer and the keyboard through what looked like a telephone network type connection called AtomNet. Runs at 62.5 kilobits per second, and it's a packetized, serial packetized one-wire network. And I looked through it and went, wow, I actually could take and adapt FujiNet to this. So we did. It took us roughly about 3 months to do the initial prototyping, 6 months of work to take and further modularize the code so that we could reuse things like our configuration program. And at the end of the day, we wound up porting the vast majority of the software that we had written for the Atari, like the ISS tracker, to work on the Atom. Come on. Hold on a second. So you got to see, hold on, if I can get, yep, here we go. So in the process, we took and ported over the Atari tools and everything over to the Atom, and in the process, we kept our philosophy of trying to take and integrate as far into the system as we possibly can and to make things look like they were part of the system to the utilities, which look like first-party Coleco software, complete with the smart key displays and everything else. And that extends to the ISS tracker as well. Because we had leveraged everything and I had done all of the software development in C, it was very easy to take and move the code from one platform to another very quickly. So, let's see. Okay. Not long after that, we found ourselves going to the Atari Lynx because Moswald wanted to work on the Atari Lynx. And that was an interesting challenge in and of itself. Because for those of you who are not familiar with the Atari Lynx, it's a portable game system with a communication port on the back of it called Comlinks. It runs at, ironically, the same speed as the AtomNet with many of the same communication modes. How serendipitous. Okay. We took the Atom code from that and quickly side ported that over. And so you get things like this, being able to run the program that you just saw a few moments ago for ISS space tracking on the Lynx. And the beautiful thing here, if you'll notice, there's no power or anything hooked up to that FujiNet device because it's getting its 5-volt power directly from the 5-volt pin that's on the Comlinks port. That's one of the beautiful things about the ESP32 is it is extremely power efficient, and you can really make it power efficient. So this ultimately culminated in all sorts of experiments. For example, we were able to show that you could not only load a piece of software on the Lynx over the network, but you could also play games over the network as well. Did I actually take and make another one here? No, I didn't. Darn it. I should have put that video here, but we can show that. Anything that I'm talking about here, as a reminder, we can take and show you in the computer history exhibit, at our exhibit just outside the Computer History Museum. So that brings us to today. And we're working on a lot of different things today. For example, just 2 weeks ago, we put together a work group in our Discord for the purposes of building out game servers. Specifically, game servers that are small, simple, easy to understand, and can be adapted for other purposes. And some of those examples include a 5-card stud game that we are currently working on right now. And so what's essentially happening here, we have a test server, and he went ahead and wrote some test fixtures, which are basically bots to play the other players so that we can test server interactions back and forth and work out the issues before we actually complete the server code. And not only that, but because we are building a platform that transcends we're building a networking platform that transcends multiple computing platforms. We're able to do things like gameplay that transcends the different hardware platforms, such as being able to play a copy of, here's a version of Othello running on the Apple II on the left, and a version running on the Atari 8-bit on the right. They're written in 2 different languages, but because they're speaking the same language, the same protocol on the wire, they can talk to each other. Doesn't matter what you decide to write it in, as long as you can speak the same thing over the wire, you can talk together. And these were very quick things to put together. It was extremely easy, and that's one of the tenets of why FujiNet is so successful. Because it's easy to use. It has something that everybody wants to do. They want to be able to load software, so that gets them into the rest of it immediately. But it's also easy to program. These two examples right here are written just in BASIC. In the case of Apple II, using basic system extension to provide ampersand commands. And on the Atari, using the central input and output I/O system. On the Commodore bring up, that uses kernel commands, so open, close, get, put, etc. In each case, we try to find the good integration point, because as we learned, it's better to be useful. It doesn't have to be fast. It has to be useful. And there are more games coming too. We have, for example, a contributed user wrote a Mancala game on the Atom that we're porting to other systems as well. And because this one is also in C, this can be ported very quickly. And so on. And because we inevitably are going to have to deal with our artificial intelligence overlords, there is a ChatGPT client for the Atari that will be ported over to other systems as well. And again, because the FujiNet can natively talk HTTP, because it can talk HTTPS, because it can parse JSON and parse XML, and because it can handle all the crypto, FujiNet is automatically in a place to handle complex network interactions with APIs. You want to do an OAuth request? Sure, not a problem. You want to talk to Google Drive? Sure, no problem. All the pieces are there. And finally, of course, the ISS tracker, which you've seen, and a news client, which I didn't put a link in for. Too bad. But also, more platforms. I'm going to start this by basically stating that we have a 10-year goal to hit every single 8-bit machine by the end of the decade, and try to start work on the 16-bit machines as well. Starting with the Apple II. The Apple II bring-up is almost complete. Jeff finished the last bits of code to push this into production just a couple of weeks ago with migrating the migrating all the disk routines to use, ironically, the remote control pulse transmission and receive hardware that's built into the ESP32. It actually worked out really well for us to actually fully simulate not only the Apple Smart Port, but Apple Disk 2 emulation as well. So Apple II is coming up extremely nicely. If I can just give it you can see right here with what's quickly becoming our Hello World application, the ISS tracker here ported over to the Apple II. And one thing about the ISS tracker, it's a good example network program because it shows something that most people would want to do with a device like this. To connect to a web service, to grab the JSON from that web service, parse that data, and then feed it back to the computer at its leisure. Let me go ahead and pull you back. Hold on. My touchpad has succumbed to battery expansion. Oops. And I'm going to have to, excuse me for a moment while I bring my presentation back up. Documents. So, Come on, tab. Okay. So we have a Commodore bring up that's happening extremely quickly. And again, our hello here, our hello world for the ISS tracker working on a Commodore 128. But also, come on. My touchpad is dead. Okay. New retro platforms, such as the Aegon Lite and the RC 2014 are coming up as well. These use an SPI connection. All of these new retro machines all have an SPI connection. And the developer that's working on this is actually, since it's working in a terminal here, he ported the ISS to do it in ASCII art. As you can see, it's pulling the data and working just fine. And we can do this because we have sufficiently modularized out the design into three main concerns. We have buses, which are the connection pieces for all of the virtual devices that exist on FujiNet. And we have a bus implementation for every system that we go after. SIO for the Atari, AtomNet for the Atom, Comlinks for the Atari Lynx, IWM, and that's the thing here. Think about the Apple II for just a second. The Apple II implementation is using the IWM chip that's present in a number of the Apple IIs, which is basically just a chip version of the Disk 2 controller. Single chip version of this Disk 2 controller. So we're using Woz's Disk 2 controller design, which is already incredibly brilliant and batshit crazy to begin with, and we're pushing network packets over it at 250 kilobits per second. When we told Woz this, his response was just fucking crazy. That was it. That was just 2 words. And we have an IEC implementation for the Commodore. We chose the IEC because, quite simply, it's there, and it's on all of the Commodore 8-bit machines. And I know some of you are saying, but it's slow, it's slow. What did I say earlier? It's not about being fast, it's about being useful. And as many of you Commodore hackers know, you can optimize talking over the IEC port using fast loaders. So we can take and leverage all of the work that's been done in the fast loader arena to make data transmission over IEC considerably faster. With that, we also have the different types of devices that we've put together. Of course, you've heard me talk about the disk device, the printer device, the network device, and the modem is basically, we took an existing ESP32 modem firmware and we chopped it into the existing firmware. So it works pretty much like that. The difference is that we have a bus device that determines when it can talk and when it can't. So depending on the different implementations that we have to put together. But we also have, as part of the network implementation, one of our biggest strengths, the network protocol adapters. This is just a simple, you can think of it like a simple CRUD API for implementing network protocols. Open, close, get, put, special. For each network protocol that you want to take and implement. And as you can see right here, not only do we have support for HTTP and HTTPS, but because we happen to have a complete crypto engine on here, we can do things like SSH. So, really? Okay. So basically, yes, you can use your Atari or your Commodore 64 or Apple II as a terminal for your Linux box, talking directly over SSH. It works. And furthermore, as I've alluded to before, each of these protocol adapters have access to channel modes to be able to parse all sorts of different documents. Currently, we have JSON and XML parsers in here. So that makes things, let's see if it goes. Demo gods are not looking good on me right now. Okay. Oh well. I will come back. So in addition to this, we also have all of our media types split out for different disk formats, different file system formats across all the different emulators. All of these are completely modular. So, for example, we had to implement ATR for Atari 8-bit. We had to implement Protos ordered disk images for the Apple II. We had to implement D64 for the Commodore 64 and so on. The thing is that each of these media types are completely autonomous and not directly connected to the disk drives that use them normally. So any of the different disk drives on different systems, network protocol adapters, whatever, can use and call file system functions from within these media types. So that opens up the possibility of being able to read disk images that are made on other platforms. It completely opens up that interoperability space automatically. Let me see if the SSH here will actually work. I'm going to see, because I really want to show this here. Oh yeah, there we go. So, I mean, as you can see right here, we have a little netcat program that's pretty much on all of the different implementations. And you're able to take and make an SSH network connection to log into your Linux box. And the thing is, because everything's using the same connection interface here, it doesn't matter whether I use an SSH URL, if I use an HTTP URL, FTP, whatever. All of the details of protocol negotiation are handled behind the scenes, and it just works. Okay. And that essentially means, what that all culminates in is the simple fact that we're building a platform in which all of the different retro computing communities can come together to do something interesting. We can play together, we can create together, we can make together, and do all sorts of interesting things together. Yeah, you saw the reverse E there. Just as an example. Again, I pull back to this because now we can make multi-platform games. We have all the infrastructure to do that. And you can do that even in languages such as BASIC. So here's an example of some code that pulls Mastodon posts right out into BASIC, doing your HTTP call, calling the JSON parser, pulling out specific bits of information from the JSON parser and displaying them, waiting a minute, and then going again. And might as well just show it. I've got the time. I'm going to wing it, as they say in the wing business. May heaven help me. So what you also see right here, we had a contributor come in and do a port of the entire FujiNet stack over to POSIX, over to Win32, so that FujiNet can run on PCs. And the eagle-eyed among you will notice that we're running inside of an emulator here. The Altera emulator for the Atari 8-bit has all the infrastructure needed to take and connect to an external device. There's a tiny little bit of Python glue which talks to the FujiNet. Jan Krupa did the first implementation over a period of about 2 weeks of free time. And it works. And as we'll see right here, we'll boot into the Mastodon client. I'll do a quick list of the program before we actually run it so that you can see it working. And yes, I know I'm tempting fate here, but I'm on a separate network connection. Oh, come on. Come on! Yes, I know. Pressing my luck. Let's try this. I'll try it one more time, and if it doesn't work, that's fine. I wanted to really prove my point. Oh, a network adapter talk, and we can't use the network. How ironic. Let's try that again. The reason that it boots up into config, ironically, is because the configuration program for all the different targets is actually in the flash of the FujiNet. So it boots directly up into its configuration program. Again, just so that you can configure your wireless network and get everything working as expected. Is my Wi-Fi up? Yes, it is. Okay, we'll try this one more time. Please work. FN4. Come on. Let's see. I want to see if I hear the beeps. It's going, but man, the network here is just, oof. It's trying. That's one of the nice things I always liked about the Atari was the loading beeps, so you knew that when things were happening. Okay, I am sorry, gentlemen, ladies and gentlemen. I'll have to punch out here. Wait, it might. I hear it going into, yep, okay, let's see. So again, we see that Mastodon listing. Thanks. Oh. We're not out of the woods yet. I'm about to run it. Let's see what happens. Hurry, before there's still time. Okay, so run, please. Up. I laugh because otherwise I would cry. So we'll try that one more time. You name it. Nope, okay. So close, yet so far. Okay, so the point being, it's real easy to use, real easy to code for, I promise. No, really. Okay, but not only that, but you have some really interesting exponents even for people that aren't coders or hackers in any way. One of the nice things that we were able to do was to implement what we called high score saving. So we are able to, and we did the first implementation as a test on the Atari. We're able to take and mark a section of a disk image to be read-write and say, well, here are the high scores. They're on these sectors. So that whenever a program tries to take and write to those sectors, it will send those across the network just fine on a disk that is otherwise mounted as read-only. And not only that, we took that in even a step further and implemented a high score leaderboard. So we take and put the disk images on a public server, people connect to them, they play the game, and they wind up doing their high scores. And we have then all of this is actually available. There's a little server program that runs back behind, reads the disk images, pulls the high scores out, and posts them in real time on the scoreboards here. And I want to find out who this CL guy is here because he has completely dominated every single score on the leaderboard, including on games that I didn't think even were possible to even get such high scores, such as if anybody's ever played Baja Buggies on the Atari 8-bit. We actually managed to clear out the high score, and we have people that actually managed to place in the leaderboard on Baja Buggies. But yeah, it's another thing that we can do to bring these communities together, and it's really easy to set up. You can do it on your own home network or at a LAN party, doesn't matter. Or you can use the public servers. It's just here. So back here. So that brings us to tomorrow. Well, it's obvious, you've already heard me say it a few times before, more platforms, more buses. And we have a lot more platforms that are coming up here. And this is where things get interesting, because you see the very first one up here, the ZX Spectrum. We have a hacker right now who is working full speed ahead on the implementation for FujiNet for the ZX Spectrum, which will plug into the expansion bus. But he is doing it in such a way to implement a generic 8-bit bus interface. And we are going to take that implementation as the baseline and the template to bring it onto everything with a card edge or a cartridge slot. This includes the PC ISA bus. So think about the IBM 5150 PC at 4.77 megahertz. You now have a useful network adapter that can load and save software and data, have the virtual printer, have the offloaded network adapter, so that now even PCs can actually do some useful things with the modern internet. Same thing for the Macintosh 128 and 512K and plus machines, which are naturally very resource-constrained machines. In this case, we're trying to go over the floppy port to take and give those machines the ability to take and use everything that we've built in the FujiNet ecosystem to do many of the same things. We have a hacker that is working on an Atari ST implementation, which will go over the ASCII port. For any of you who are familiar with the system or not familiar with the system, the ASCII port is SCSI. It's just truncated slightly. So we can take the lessons learned there and move over to machines with a SCSI port. But because we have this generic bus interface that we've built through, and just so that everybody's aware, we've passed all of the circuit design and all of the circuit simulation. Owen spent close to about 6 months just simulating this in Logisim and working out all the edge cases before he ever took to breadboard. So we know the circuit works. We can take all of this and move it over not just into computers, but over into game consoles. Imagine being able to take the games that we built over in the FujiNet space for the Atari 8-bit, Apple II, Commodore 64, etc., and moving them over to the Nintendo Entertainment System, the Sega Genesis, etc. All of that suddenly becomes possible, especially because of the modern toolkits that have all emerged from these respective communities to make this sort of thing possible, married to our bus interface. We basically want to do all of them. We want to do all of them. So that means more buses, the generic parallel bus, the SCSI bus, and even an RS-232 interface as a plan Z. For everything else, we have a path forward on all of this. That brings us to the lessons that we've learned. Again, and I've said this several times, and I will say it again, being useful is better than being fast. If you take and spend the time to integrate into the operating systems and into the communities, into the way that they do things and understand why things are the way that they are, to be able to provide something that makes sense to each of their target users, they will use what you make. And this has been proven out by the fact that as of right now, from my latest tallies, even though we don't sell all the FujiNets, we work with vendors in all of their respective communities. In the Atari community, for example, there are approximately 5,000 units that are being used actively right now, today. So I think this approach has basically been proven out. Integrate wherever you can. Integrate into the operating system, but also integrate into the community. Show them with the basic things that you could, with the basic things that you can do, and with what we could do. Being able to load software, being able to save data over the network easily, being able to use the virtual printer. That brings them into using the network device. And again, you can say that all three of these are basically just interconnected and socially oriented features. You find the feature that everybody wants, and you make it work well. Oh my God. We spent so much time making the virtual disk work as well as we possibly could and hammered everything out. And you know what? That ultimately means right now, 5,000 units. I get bugs from maybe a dozen people for features that are outside that scope. So I think we're doing extremely well there. So finally, I want to get to the thank yous here, and since I have a little bit of time, I'll go through some of them here. This is Moswald's project. He started the hardware design 2 years before I ever met him. It started off as a modem, and it's my fault that this thing got moved into 80,000 other things. But these were all things that fell out of the design that he started, simply by connecting all the pins together, making sure that everything was accessible. Jeff. With Jeff's help, we were able to take and move everything from these dinky little Arduino sketches that we were doing into a production-ready framework, Platform I/O, to add things like the unit tests, to add things like all of the modular compiling, to add things like being able to pull things in from other toolkits very easily. All of the infrastructure that this thing gives us. I want to thank Andy Diller, because Andy is, in a lot of ways, he's acting as a head marketer on the product, making sure that people know about FujiNet and trying to get the word out. He's also helping us try to get some of our, we're not a business, but we're trying to get some things in place so that we can expand out a bit further. And he's instrumental with that. I describe FujiNet as a tree fort. It's a gigantic tree fort. People come in, they see what we're working on, and sometimes they go off in a corner and they hack on something with pieces that we pull from the middle. And then they come back and they say, look what I made. Isn't this awesome? Yes, absolutely. Here, you can have it. Great. And sometimes they leave. And that was the case with Oscar. Oscar came in and single-handedly ported our entire code base from Arduino to ESP-IDF in a week and a half. The whole thing. And it worked. The crazy thing is it worked the first time. Wow. So, Jamie Johnston. Some of you have seen the big burly bastard. He came in and was working on a separate project in parallel for Commodore machines called Meatloaf. Still working on it. But he came in and saw what we were doing and said, hey, would you like to use some of our code for the Commodore side of things? Yes, we would, absolutely. So he's not only donated code, but he has donated time and energy to help integrate it into FujiNet. And I am forever thankful for his time and his energy. I'm thankful to every person who spends time on this project, because they could be doing anything else at all, and they choose to do this. And that makes me happy. William Schaub. I have to take and mention this guy. If most of you will never bump into him or know what he does, but he is an absolute amazing archaeologist. He has a natural talent for finding the piece of information that nobody else can find. Finding it, uncoupling it, understanding it, and disseminating all of that information to the rest of the group. He has been absolutely instrumental in getting the edge cases in the Apple II implementation worked out, kinks worked out, obscure smart port bugs, obscure firmware bugs, nailed it. And I am absolutely thankful that he decided to come work with us on this project. Norman Davey, industry veteran from countless companies, I can't even remember. Everything under the sun, including Electronic Arts. He's writing example code. He's writing game server code. He's writing bits and pieces that other people can use to write their own applications. And we're putting all of that in the FujiNet application repository. Marcin worked on the Bluetooth implementation. It has a Bluetooth stack in there because it's an ESP32. And there was a Bluetooth adapter for the Atari. He came in, implemented SIO2BT, said thank you very much, and he left. And sometimes it's just like that. Mark Fisher has been absolutely essential in working on the web front end and the web UI that FujiNet has, making it work well, modularizing it out for different platforms, doing all of the dirty work that for all that need to happening. And Steve Boswell, you've heard me mention before, he was with us from the beginning. He gave us our logo, did some of our first hardware prototypes, and still has a TNFS server, public TNFS server with tons of Atari software. Frank Rachel is instrumental in taking the cross-platform configuration program that I put together and breaking it out so that it can handle multiple platforms. So you can have the Apple II version, so you can have the Commodore version, so you can have all these different implementations, all from the same C code. People like Eric Labra, who is writing FujiNet software for the Apple II GS. He wrote a Trivial Pursuit game. Rob Justice, who some of you know from the Apple II community, has been absolutely instrumental in helping us iron out SmartPort problems. Owen, who's working on the ZX Spectrum implementation, who I've already talked about, and so many more. So that brings me to the question that some of you may have. How can you help? We have multiple ways in which you can contact us, but our primary way is to get on our Discord. We're all here, we all congregate there, we all work there, we all bounce things back and forth. We have a GitHub repository for all the applications, FujiNet Heart, FujiNet apps, so you can have all of the example apps for everything that you could possibly think of. If I can pull into that. And you've got tons and tons and tons of examples. And these actually go hand in hand with the documentation that's in the wiki. Now, as to whether or not this will load is going to be another question. And I do apologize here. It seems I had more to show, but the network is preventing me from taking and connecting to some of these external resources. But they are there. You can also take, because this is an open project, this doesn't mean just the application software, it doesn't mean just the firmware, but it means also the hardware. Our hardware repository on GitHub has everything that you need to make a FujiNet. Everything from the case designs, to the board layouts, to the bill of materials for components, how much they cost, breakdowns, everything is all up there on the hardware repo. And most importantly, because this is, and I use this term a lot, for a lot of us it's soul repair. We want people to use it. We want people to take and build these things for their respective communities. So if you can pick up a soldering iron and help build these things, please help. And of course, the entire firmware implementation is also up there, so that you can upload the firmware to the new devices that you build, but also to understand how it works and to make things like new protocol adapters, new bus implementations, new device implementations. A little statistic, right now, even with all of the platforms that we currently have in the code base, all the devices that we currently support, we're only using a total of less than a third of our available code space. We have over 68% empty space in our flash memory space that can be used for additional firmware. So there's plenty of room for expansion, plenty of room for growth, plenty of room for possibilities. More info, of course. Everything that I've talked to here builds off of the main website, fujinet.online. Again, I wish I could go to it, but, network. But from here, you have access to the wiki that you see up above, the ability to get the firmware flasher so that you can upgrade your FujiNet. Our shop link has basically turned into places where you can see vendors that make FujiNet. So again, if you're a vendor, if you know vendors, talk to them, tug their shoulder, say, please make FujiNets for us. Beg them. We want people to make them. They are simple, they are cheap to make. I did neglect to mention, with everything, with all the functionality that we have, we are able to stay below the magic $100 price point. The average price of a FujiNet today is $85, and that really has to do more with the current state of the semiconductor market than anything else. Because when we started, it was $20 cheaper. So, anyway, that's pretty much it. We have about 8.5 minutes for questions. Does anybody have any? Yeah.
Can you quickly go over the difference between, I was on the Brewing Academy site the other day, and they have version 1.
Oh, the versions. Okay. So this gentleman here is asking about the different versions of the Atari FujiNet. I'm going to qualify this by saying they're not important. The same firmware runs on all the different versions of the Atari FujiNet. What these are slight hardware revisions as people report hardware interoperability bugs with us. Things like, I plugged in my tower of 18 1050s into the back and all of a sudden it doesn't work. Why doesn't it work? Please fix it. Okay, so it's things like adding a capacitor here, adding a resistor here, or, just trying to improve the hardware coupling. So what version you get, especially for the ones that are out there right now, do not matter. And we make a fundamental promise that whichever hardware version that you buy, you're going to be able to flash whatever version of the firmware that's currently available onto it. Period. End of story. That's a promise from me. Dean?
Do you know if anybody's working or looking at the MSX?
Nobody is, okay, so Dean asked if anybody's looking at the MSX platform. Nobody yet, but the moment that somebody does, what we will do is we will provide them a space for them to be able to do their bring-ups, and we will work with them to try and get them up to speed as much as possible. With that, I will qualify that to say that I think platforms like the MSX, which use cartridge slots, will become a lot more feasible once we have a generic bus interface. Yes, sir?
Going forward, CPM character-based
Yes.
machines. Is there anybody currently working in this?
So the current work there that's being done is actually being done on the RC 2014, and the lessons learned there on the RC 2014, because it has a CPM implementation, can carry forward to other CPM machines as well. I've made reference to the fact that we're trying to get other buses up and running. So, of course, the 8-bit bus that I mentioned before, but we're also going to do an RS-232 implementation as well. So, again, it's just another bus type. Yes, like I said, when I say we're going to get onto all the machines, I mean all of them. Anybody? Yes, sir.
You mentioned that the Apple II Disk 2 drive is working now?
Yes.
Oh, cool.
Plain as, yes. The way we actually did that one is an interesting story in and of itself. We are actually using a macro block inside the ESP32 called the RMT, which is quite literally the remote control transmitter. It's meant to send pulse trains in a reticulating loop. So we've taken that piece of hardware, modified the software around it so that we can simulate the flux transitions that are happening on a disk and using the hardware to take and push that. And because it's all in hardware and because it's a tightly coupled state machine, the timing is perfect. Yes.
Oh,
It-
sorry, I have one other question.
Yes.
Does it emulate one or two disk drives?
It will currently emulate one disk drive. I say that, and I remember, oh yes, DB19. It might actually, I think it might actually do two. You'll have to ask Jeff.
He's at the table.
Yes, he's at the table. And please, come by the table, see what we have. We will take and demonstrate anything to you that you want to see. Anybody else? Okay. Thank you.